Hello, and today I'll be proving this following statement using mathematical induction. Let's have a look at the question. We are trying to prove that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times dot 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 times, and then at the end times 1 minus 1 over n squared is equal to n plus 1 divided by 2n. And we're trying to prove this is true for all n at least 2. Okay, so in a mathematical induction proof, the first thing we'll prove is the base case. The base case is the smallest possible value of n, which is n equals 2. So when n is equal to 2, the left-hand side, since the product goes from 2 to n, but since n is equal to 2, the left-hand side is just going to be 1 minus 1 over 2 squared is 1 minus 1 over 4 is equal to 3 over 4. The right-hand side is equal to n plus 1 divided by 2n, and n plus 1 divided by 2n is 2 plus 1 divided by 4. This is also equal to 3 over 4. So the left-hand side is equal to the right-hand side for when n is equal to 2. So this left-hand side is equal to right-hand side, it means we've proven the base case. After the base case comes the inductive step. So in the inductive step, we are assuming statement is true for some value of n, which we'll call k, and k is at least 2. And we are trying to prove it is true for n equals k plus 1. Okay, so we've assumed it is true for n equals k, so we can put k into this equation, and that's our inductive hypothesis or our assumption. So what we have is 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times dot 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 times 1 minus 1 over k squared is equal to k plus 1 divided by 2k. So when n equals k plus 1 now, okay, so also this is the inductive hypothesis. When n is equal to k plus 1, you're going to have the left-hand side is equal to 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times dot dot dot. You have 1 minus 1 over k squared, but we also have, since n is equal to k plus 1, so this is, I just write a note here where n is equal to k plus 1. We also have the final term, which is 1 over 1 plus k plus 1 squared. Okay, so what we can see is if we use the inductive hypothesis, you can see this entire part of the product we can just replace with k plus 1 divided by 2k because we've assumed it by the inductive hypothesis. So you can replace this entire thing with k plus 1 divided by 2k, and we times it by 1 minus 1 over k plus 1 squared. Now we have k plus 1 divided by 2k times, and if you do it all, the whole fraction under a common denominator, we'll have this. And now we can do some cancellation. We can cancel out the k plus 1 here and here. And we have 1 over 2k times, the numerator is k squared plus 2k plus 1 minus 1. And since we deleted one of the k plus 1s now, the denominator is k plus 1. Okay, the numerator of the entire fraction is k squared plus 2k, and the denominator is 2k times k plus 1, and we can factorize this as k times k plus 2 divided by 2k times k plus 1, and now we cancel out the k's to get k plus 2 divided by 2 times k plus 1, and we can write this as k plus 1 divided by 2k plus 1. And in fact, this means the left hand side is equal to the correct right hand side, because remember the right hand side was n plus 1 over 2n, where we are substituting n equals k plus 1. So we have proven that the left hand side is equal to the right hand side where n is equal to k plus 1, because we have k plus 1 plus 1 divided by 2 times k plus 1. Okay, so we've successfully proven the inductive step. So we've successfully proven that the statement is true for n equals k plus 1 if you're given it is true for n equals k. So it follows by mathematical induction the statement is true for all n at least 2. Okay, so the basic outline of the proof again, to summarize, we first prove it for the base case of n equals 2. And then we prove the inductive step, which is if it is true for some value of k, then it is true for the next value, which is k plus 1. And combining them is our complete mathematical induction proof that the statement is true for all n at least 2. Okay, so that's it for this video. Hope you enjoyed, and thanks for watching.